Hi everyone. Today we're going to study expected value and variance of continuous random variable. Let us see some introduction here. We have this graph of f of x. This is the graph. We let capital X be the random variable with the image set capital X of capital S defined over the interval. We know that the random variable, the capital X, is between A and B, and each probability P of X, where this capital X is between A and B, is well defined. Suppose a function from R to R is a piecewise continuous function. That is the probability of this capital X from A to B is the area, and the area is this portion. Under the curve, x-axis, and the interval of x from A to B. Thus, area is the probability of capital X from A to B. The formula is here. The definite integral from A to B of the function f of x dx. Here, capital X is continuous random variable. And we see these two conditions. The first is f of x must be greater or equal to 0. Second condition, the definite integral from A to B of f of x dx equals 1. Now let us study expected value and variance. Let's begin with the expected value, and our symbol is still E of capital X. Sometimes we write this as the mean as symbolized by the mu. This is equal to the definite integral from A to B of x multiplied by f of x dx. Now the variance. We write the symbol var of capital X. Sometimes we write this as rho square. This is equal to the definite integral from A to B, x squared times f of x dx, then minus the mu square. Again, the mu is the expected value. For the standard deviation, we write SD of x. This is simply the square root of the variance. So we see here the symbol, the square root of var of x. Let us see this example. Find the expected value and variance for the distribution. F of x equals 1/2 of x when x is between 0 and 2. And f of x is 0 when x is otherwise. Let's begin with the expected value, E of capital X, and we have this formula. Substituting the corresponding values, so we have now the definite integral from 0 to 2. These are the limits, and we got this from this portion. The x here we copy here, multiplied by the function f of x. Our f of x is 1/2 times x, and we can write it as x over 2. Then the dx. Simplifying this, we multiply x and x, so we will get x squared. And this denominator too, we will move it outside the integral symbol. So we have now this 1/2 times the integral from 0 to 2 of x squared dx. Let us now integrate the function. In here, we're going to use the power rule of integration, and here is the formula. So, the integral of x squared becomes x cubed over 3. And this 1/2 we'll just copy down here. Simplifying this, we multiply the 2 and the 3. So we have x cubed over 6. And then, let us evaluate this with the limits of integration from 0 to 2. So we have now 2 cubed over 6 minus 0 cubed over 6. Simplifying further, the second fraction here will come down to 0. So 2 cubed over 6 will get 8 over 6. And the lowest term is simply 4 over 3. This is the expected value, or we say this is the mean. Now let's go to the variance. The formula is here. Let us now substitute the corresponding values. So we have the definite integral from 0 to 2. X squared, we simply copy here. The f of x is that x over 2 dx is copied down here minus the mu square. We got the value of mu from the expected value, so we write here 4 over 3 and the quantity is squared. Let us simplify the integral. So we have x squared times x, that would be x cubed. Again, the denominator 2 becomes a fraction or a constant that we will move outside the integral. So we have now 1/2 times the definite integral from 0 to 2 of x cubed dx minus, we simplify now this square of 4 over 3. We have 16 over 9. Let us now simplify the integral. Using the power rule, the x cubed here becomes x power 4 over 4. Then we copy the 1/2 down here, minus the 16 over 9. Let us simplify the fractions here. The 2 multiplied by 4, we will get x power 4 over 8. Let us now evaluate this with respect to the limits from 0 to 2. So this value here would be 2 raised to 4 over 8 minus 0 raised to 4 over 8. The second fraction here will just be 0. Now, the 2 raised to 4 is 16. 16 over 8 is 2. So all the groupings here will be 2. Then minus 16 over 9. The difference here will give us 2 over 9. This is the variance. This is the final answer. Again, expected value is 4 over 3 and the variance is 2 over 9. I hope you learned something from this video. See you again next time.